So welcome everyone to the Biological Data Standards Cluster meeting for this month. And what we've been doing recently is hopefully you all are familiar with the primer, and we realized that the primer is sort of just a quick introduction to standards, but it doesn't really help you with deciding which ones you might want to apply to your data. So we've been asking experts related to those standards to come and talk to us and tell us about how they are usable for biological data, why you might want to use them for biological data. And so we're focusing on the questions: what is the best, most common use case for this standard for biological data? What does this standard uniquely offer for biological data that other standards don't? And what are the limitations of this standard for biological data? What doesn't it cover? And so with that, I am going to kick off our data standards panel. And we are going to start with John Wycherek. Sorry. So it's my pleasure to introduce John Wycherek, an information architect and developer of distributed data networks such as VertNet and its predecessors. He's also the author of the Georeferencing Best Practices Guide and various tools for georeferencing. He's a co-author of the Darwin Core Standard and convener of the Darwin Core Maintenance Group, and a longtime collaborator with GBIF, currently working on the Diversifying the GBIF Data Model project. John is here to tell us about Darwin Core and what it offers for biological data. And so, John, I will stop sharing my screen and turn it over to you.
Okay, thanks, Abby. Can you hear me?
I can hear you.
Excellent. Okay, so Darwin Core is an evolving standard, and that it's evolving doesn't mean that it isn't mature. It's actually quite the opposite. It's evolving because the need to do so has been recognized. At the core of Darwin Core is what we would call a bag of terms that are organized in classes. Classes with names like organism, occurrence, taxon, identification, event, location, and such. And the greatest value of the terms is their tried and refined definitions with their commentaries and examples. It makes them easy to use. And they can be used in any context where this need for clarity and consistency is beneficial. And it's particularly the case when data are shared, which is what makes it a standard. The most popular means of sharing biodiversity data, and the most common use case for it, is occurrence data. And that is through a Darwin Core archive, which is a specific implementation to package data and its metadata using Darwin Core terms in CSV files, and with added metadata that's machine actionable to explain how all the data fits together. The Global Biodiversity Information Facility, or GBIF, currently aggregates more than 2 billion occurrence records, and mostly using Darwin Core archives. Darwin Core archives are based on 3 possible distinct biodiversity perspectives. These are occurrences, which is the cross-section of organisms at a place in and time, often with a protocol used for detection. Events, and taxa. Around these, there's the freedom to define extensions to deal with details that aren't found in simple Darwin Core. And the extensions include things such as chronometric age, identification histories, associated multimedia, taxon distributions, and on and on. In principle, Darwin Core could cover any biological data, but it's only easy to do so for the things that have been specifically developed so far, either within the cores or with the extensions. And in Darwin Core implementations to date, the Darwin Core archive, the biggest obstacle has been the limitation of a star schema. That is, the data model for publishing is only able to accommodate one level of depth of relationships between data in the CSV files. But work is now underway through GBIF to overcome that limitation. The project is one that Abby just mentioned, Diversifying the GBIF Data Model, and it's based on a large body of use cases each of which presents a distinct challenge that can't be met with Darwin Core Archive star schemas today. So that's the basic panorama and landscape for Darwin Core. What it doesn't do specifically, it tries to do through its extensions. So in summary, the best thing about Darwin Core is the sense of community and freedom to engage in a consensus building process to evolve the standard and meet any new needs that arise.
Great, that was awesome. Thanks so much, John. I really appreciate it.
Welcome.
And so we probably can, if we have one or two quick questions right now, we could take them for John. We will have a discussion after Roy presents as well. But if there were any Darwin Core specific questions, maybe one or two right now, we could take those. Here.
Thanks, Abby. Thanks, John, for the overview. Just a question on serialization of the Darwin Core archive. I know it's serialized in a couple of forms, but what's the standard way, and is there a way to sort of externalize different serializations like RDF or JSON modes, etc.?
Yeah, that gets into the confusion about what Darwin Core is. The Darwin Core terms themselves are described and based on RDF and can be serialized as such. There's actually an entire separate namespace for Darwin Core as RDF. But I didn't discuss that here because it's not the most common way. The most common way is through this Darwin Core archive, which is all serialized. It's actually a zip file that contains CSV files and an XML file that describes how those CSV files fit together, plus an XML file that's actually EML, the ecological markup language, describing the characteristics of the data set. Those are the two main serialization methods. There are also guides for how to do it in XML, but nobody does that anymore.
Okay, thanks a lot. And I think, I feel like there's a shift coming eventually that people would want the whole archive in a fully serialized format with structural metadata or so. And I think, that is a good setup already that it's stable enough to do that. Thanks.
Yeah, and the terms being solid and being in RDF is a really good start there too. Yeah.
Great, thanks, Pierre, for the question. All right, so next up, I am excited to introduce Roy Lowry. He is an employee with the British Oceanographic Data Center, who held several roles for 37 years before retiring in 2018. He specialized in biogeochemical data in 1990s, chairing JGOF's data management task team for over a decade, and developed interest in semantic interoperability from around 2002. He's been involved with the Climate and Forecast Parameter CF parameter semantics standard names since 2005, and the primary architect and content manager for the NERC vocabulary server from 2005 to 2018. He's still engaged with NVS, the NERC vocabulary server, and CF as Emeritus Fellow, and will be talking to us today about what Climate and Forecast offers for biological data.
Right, hi folks. Okay, I assume you can still see and hear me. I've got notes in front of me. Yeah, okay?
Yes.
Okay, so standards are created generally for a use case where interoperability between sets of data are required. And if they work, then other use cases start to look to that standard and to see if it will work. And it may get used as is, or the standard may change, evolve by consensus discussion, by negotiation with the standard governance or other methods. Or in some cases, which I've seen, don't particularly like the standard, may be used very imaginatively, what I call shoehorning, in where people try and make the standard do something for which it wasn't designed at all. Kind of thing. You can have metadata governed by control vocabularies, and you start to get control vocabularies with entries that are lists. And this is basically someone trying to shoehorn the data model to turn a one-to-one relationship into one-to-many. And as a general rule, the closer data are to the original standard use case, the better the result's going to be. So CF, Climate and Forecast Metadata Conventions, is its full name, was created to provide interoperability required for the IPCC global climate model comparisons. It was developed to support log data. There was a large international project, Ocean Sites, who had time series and profiles, moored instrument data, and they modified their data to fit a CF gridded data model. Project I was largely concerned with CDataNet, used CF version 1.7, which introduced feature type extensions to handle profiles, time series, trajectories, and these were formed from either logged instruments or sample measurement data. And then the final evolution, which I put into CF 1.8, was to enable the standard biological spreadsheet with model with, let's say you have sample as the column and taxon as the row, very common biological data type. And in response to various requests, that was put into CF. Biological data best suited to CF. CF really loves gridded data. Satellite images, ocean color. I was working with a couple of guys from the Irish Marine Institute who were trying to deal with reflectance with over 400 different single wavelengths for chlorophyll. And we found there's a very neat way of doing that within CF. Things like model output. Models quite often produce grids, and grids fall straight into CF. Also, if you're producing integrated data products, the kind of thing we were building in EMODNet, where we'd have shellfish contaminant maps all around the European coastal seas, and they sat really nicely into CF. Works really well with spatial temporal features. By that I mean profiles, i.e. where you've got data measured at different depths, time series where you've got data measured at single points at different times, or trajectories where something like a ship's cruise track. For biological data, we've used it for fluorometers, for chlorophyll, acoustic biomass, ship finding echo sounder data, that kind of thing. It was used a lot in CDataNet for simple water and sediment sample biogeochemistry data. But one general guideline is that the larger the volume of the data is getting closer to CF's origin, and therefore is more likely to work best. What it brings to biological data, it has semantic interoperability support with the standard names. So these are a standardized way of describing what was measured in a measurement. Might sound a fairly trivial thing, but having received many spreadsheets with very imaginative column headings describing what the measurement was, it's really essential to have a good vocabulary for what is measurement. The standard names are maintained. There's a transparent community peer review process on GitHub. There's also a very strong technical governance behind the standard names. So versions are managed and published, and all previous versions are preserved. And also all serving is done from synchronized sources. So whenever you get hold of the standard names, you know you've got the current version and you're using the same version as everyone else. Another thing it brings is a common framework for biological and other data. You can have a single container, i.e. a netcdf file, that's got biological data plus the related physical and chemical data. So you can have temperature and salinity fields and biological sample data. We were using tools like Ocean Data View, which is a visualization product produced by Rainer Slitzer from Alfred Wegener Institute, or DIVA, which is an objective analysis tool that's came out of the University of Liège, to provide analysis and also multidisciplinary visualization of such containers. With eModNet, CDataNet gathered together loads and loads of European data. eModNet was the project where these data had to be put into products and visualizations that were given to policymakers. And tools like this, and some of the integration was automated using semantic descriptors of the measurements. So, okay. Right, CF limitations. CF sits on a netcdf backbone. It's far more suited to those who work with Linux and Python scripts than it is to those who work with Excel. So if the Excel users are going to use CF, they need support from tool development. Also, being netcdf, it's very awkward handling text. There are data types where you need to have a reason for using CF. Using biogeochemistry sample data, it works well in spreadsheets, but if you do want to bring it together with physical and chemical, then CF helps. Taxonomic data, it works, but it's not that strong. You really have to have a reason. Why am I using CF for this? Not that CF is a standard that I've got these data, I'll use CF. And the areas where I would forget CF, things like genome data, massive text strings, anything with loads and loads of text, behavioral descriptions, that kind of data, or any data with complex embedded relationships. The IC's hydrographer, Harry Dooley, always used to quote the example of a gut pigment analysis from a copepod in a fish stomach. And can your format or can your standard handle that? And as far as CF goes, in that case, I think it's no. So anything with complex relationships, really, you want things that have XML-based formats or things like that work much better for that. So anyway, so that is my little spiel. Hope they're not going on too long. I wasn't timing myself, but there we go.
Thank you so much, Roy. I really appreciate it. It was great to hear the sort of benefits and uses of climate and forecast. And I definitely understand it's the variability in the headers for data that you can see is definitely something that I think standards can help with. So thank you so much. And so are there any questions specific for Roy right now that we might about climate and forecast?
Yeah, Abby, I have a question, Hassan here.
Okay, go ahead, Hassan.
Roy, thank you very much for this presentation. I missed John's presentation, but that's fine. I'm aware, I know what's going on with Darwin Core, but I think with CF is more interesting here. So my question to you, Roy, do you think encouraging the use of CF at the georeferencing and let's say latitude, longitude, time, what I mean with that is that should we strive to do that with CF than other standards, and also altitude and depth, something that seems like reasonable, but I want to hear from you what you think when it comes to integrating between physics and biology or ecology, whatever that is.
Yeah, I mean, CF, fundamentally inside CF are, excuse me, either arrays or vectors. These arrays have coordinates, so you can have a coordinates, you can have a multi-dimensional array with coordinates, latitude, longitude, time, depth. You can also put other coordinates in there, which make it more powerful. You can use taxon as a coordinate, or you can use things like, if you're dealing with ocean color data, you can use wavelength as a coordinate. So it's very, very powerful for handling those kind of georeference. And then the 1.7 extensions actually go into the concept of feature types. So you have specifically defined data models as point, which I've not really used much. There's profile, which is for data that vary as a function of depth. Time series, which is point data varying as a function of time, or for trajectory, which can be 2D, it can also be 3D. So if you've got a towed undulator measuring chlorophyll, you can handle those 3D trajectories quite easily in CF. It's what NetCDF was made for.
Oh, that makes sense.
So
Thanks,
just
Roy.
a quick follow-up. Sorry, just a quick follow-up with Roy, because we have a great chance to force that with the web services that we are using, and some communities are using. I'm not saying everyone. I mean, because within ERDAP, as a platform that we are using, I use, it does seem like that's straightforward, because that makes the CF. Well, I'm not, again, it depends what CF we're talking about, but it's a level of the CF for the georeferencing information and the time and the depth and altitude. It's uniform across all the data set that we integrate within ERDAP. Do you encourage that approach?
Yeah.
Thank you. That's all I want to ask. Thank you.
That's what we did in CDataNet.
Makes sense. Yeah, I think maybe the issue is when you don't have those. I feel like not all biological data has all of those different parameters with it. So I think that could be maybe part of what could make it difficult. But Matt, you have your hand raised.
Yeah, I wanted to say thank you to John and Roy for your presentations. I definitely learned a lot, and I was curious. John was mentioning kind of how there could be like hierarchical relationships within Darwin Core, and you can connect, and they're looking into how the model might be expanding in the future. And I'm curious, Roy, if the CF community is looking at how they can maybe encapsulate some of those type of relationships, and kind of where you might be seeing CF go in the future with respect to biological data.
I haven't seen, I'm trying to think, there's a whole load of proposals just been put forward for the CF conference in September for ways that they would like to see the standard develop. I don't think embedding hierarchical relationships is on the radar, but I'm pretty much, you have to appreciate, I'm retired, I concentrate on the standard names, and therefore I look at those things, I read them once, and I would need to go and read through those emails again to have a definitive answer. But I think CF has a GitHub. There's two GitHub streams. One is for dealing with the development of standard names. The other is for the development of the standards. And these are totally open and public, so anyone can go in and see what's being proposed. I mean, that's what these emails were about, was setting up a set of GitHub tickets for things that were going to be dealt with in a hackathon at the conference. So I'd say go and have a look at the GitHub.
Great. Great.
Hey, Roy, I have a question. Can you hear me?
Yep, we
Yep.
can hear you.
Okay, yeah, this is Jonathan Blythe. I have a question about the way the taxonomic names have been implemented. See, for me, I thought that we would use taxonomy as the standard names for variables. Is that the way it's implemented, or did I misunderstand that?
No, we decided, oh, okay. I mean, the primary parameter description I was involved with was the usage vocabulary and NERC vocabulary service. And that's where I did my learning. When it came to going to CF, with chemistry, we'd missed the boat, and we were starting to get more and more standard names for given chemical measurements. When it came to biology, we didn't want the explosion in the number of standard names that I got with NVS. So the idea was to treat taxon as a coordinate. So it becomes another dimension in your array. And it works. I mean, the HOTS are using it for some of their data. But it's
no, that's fine. Then what do we do for? You mentioned something about tabular data. Is there a way that tabular data can be represented in the HDF format that is more native to the way tabular data are organized, or are you actually reformatting it into a very sparse array?
To me, tabular, it just seems to sit naturally as a simple array within the NetCDF. I mean, the whole point with NetCDF, HDF, or any of these things is you don't actually get your hands dirty down in the bits and bytes of the format. What you're actually dealing with is an API. I found no problem at all. It just seemed totally natural to me to have your tabular data, and you just simply take each axis of the tabular data and treat that as a coordinate.
Okay, thanks for the explanation.
There was a question in the chat. I know, Matt, that you put a link in, but people were wondering how to find resources for learning about climate and forecast and how to use it. Roy, do you see that link that Matt provided in the chat? Is that the one you would recommend as well?
Yeah, I mean that see, conventions.org. There you will find the latest version of the conventions. It's getting to be quite a weighty document, but it's not too bad a read.
Okay. Great.
Another thing people might, I don't know if people realize that standards can be layered or profiled. I mean, what we did in CDataNet was we took CDataNet, CF took NetCDF as the base standard, and then put a load of conventions on top of that as another layer. And then what we did in CDataNet was we put another layer of conventions on. So, for example, we added the NVS semantic descriptions as well as the CDataNet semantic descriptions, because CF says that people are perfectly at liberty to add extra attributes. You have attributes that CDataNet that CF define the name and have to be there, but there's nothing to say that you can't add your own additional attribute set. And another thing some people in CDataNet have done is to add on top of the CDataNet standard other standards for particular data types. So for example, ADCP data, there are certain metadata parameters that people want to be there. So you just profile the standard and add a few more rules on top. And what you end up with is something that any CF knowledgeable tool will read, because the CF knowledgeable tool doesn't know about all these extra bits, it just ignores them. Or you can develop your own tools that work with a specific profile. So it's quite a powerful way of doing things.
Yeah, definitely. Yeah, for me in my work with Darwin Core, I've definitely felt that the community is really the coming together and deciding together how you want to model the data and what to put in different places and what might be missing that you need to add. That sort of interaction is what really, is the power of what's happening, which it sounds like that's what you're talking about with the profiles. Stace, did you want to kind of bring your comments, say your comment out loud?
Hi, it's Stace from Woods Hole. I will, well, I'm on my home computer, so I don't know if I should show myself, but whatever, I will. Todd did. Here. I don't know what I'm going to look like here. Oh yeah, it's a terrible home computer. Hi. Yeah, so I really appreciate both speakers' perspectives. That was so awesome. And my question was with regard to, it's kind of easy on the ends, right? Like if you're working with named taxa, I guide people towards Darwin Core, if not the full standard, using at least the terms. If you're working with environmental data, modeled output in a gridded space, I'd use CF and NetCDF. But there's a lot of decisions that I have to make when someone is interested in functional groups, for example, not non-named taxa, or when we're doing model data for, and this just came up this week, model data for a sea scallop, and we were trying to figure out how to get the taxonomic standardization into the data set for that one so that someone would know it was the certain species from the worms database. So I'm interested in your perspective on what about the in-between? Roy, it sounded like NetCF and NetCDF can contain just about everything, but Darwin Core is still good for the name taxa. So what do we do?
Yeah, I mean, the reason I would start putting name taxa into CF is because I wanted to get it into a common container with other data types, because I have visualization tools that, I mean, one of the examples in EMODNet, what we wanted to do was, well, what we were required to do by the EU decision makers is to provide them with maps of contaminant in shellfish. And when you get all your base data, what you have is the various contaminants, several hundred contaminants in individual taxa. So in Northern Europe, it's the blue mussel. France is interested in oysters and palud. Italy's interested in the Mediterranean mussel. And what we wanted to do was to integrate this lot. And what Rainer built into ODV was software that recognized, we built an AI engine that recognized that shellfish may go one-to-many to all of these individual taxa names, and then it would trawl through the data, identify the original taxa, and build an integration using Diva to do the objective analysis to give us the array that was then used for the presentation that was given to the decision makers. So that was a strong, compelling reason for us to get the taxonomic data into CF. So it depends on your use case. If you're purely doing GBIF, OBIS type, biodiversity, geographical distribution, I wouldn't go near CF. But that was where I say there are certain data types where you have to have a driving use case to go in CF. So you get CF no-brainers, you get CF no ways, and then in the middle you get, I have to have a good reason for going that route.
Great, thanks, Roy. John, did you have any comments on like functional groups or any part of this?
Questions. To me, it seems like the direction here would be to enable CF to take care of the parts of Darwin Core that are needed, and then it could be a full package. But I don't know the details enough. I'm not expert. I'm not anything in this field to say that that's just ridiculous what I'm saying. But just from intuition's sake, one package is better than two. So is it reasonable to think about some Darwin Core in CF?
I was using Darwin Core as a model for when I was building the taxonomic extensions into CF. I'm trying to think, there was someone I was communicating with an email, but I'm afraid I've forgotten the name, someone in the States.
I think it was me. I was the one
was
that
you,
was
was it?
pushing. Yeah, I was saying,
Okay.
because I was trying to get the standard name to be a scientific name rather than biological taxon name, so that it could align directly with Darwin Core. And I might go find that GitHub ticket just so we have it here. But
Mm-hmm. Right, okay. So
it's lost
Yeah.
on me what exactly the problem is. So I'm sorry. In the integration of the two sides of the equation here.
I think it lines. I do think it lines up. It it's just that CF decided to call it something slightly different, but I think that they are functionally the same scientific name from Darwin Core and biological taxon name from CF, and then also CF has biological taxon ID or identifier or something. Sorry, I'd have to go look this up, Roy. I apologize. That would, in my mind, matches up with scientific name ID from Darwin Core.
But does any of that help to address Stace's issue, the one she's talking about?
I don't know. Yeah.
These were basically there were specific standard names that standard. I was trying to get them as aligned as I could functionally to Darwin Core. But one of the problems with CF is it has a lot of precedents, and so trying to match the precedents to the precedents of another standard, you sometimes have to agree to use different words for what is roughly the same thing, but then understand that they are roughly the same thing. It's just a fact of life. One thing I would say about functional groups, the solution in CF that we decided on, it's pragmatic rather than anything brilliantly intellectual, is if you have a functional, something that is a functional, trophic, morphological group, then that term actually goes into standard names. We're only using the taxon dimension in cases where things are either derived in defined in either itis or worms. So we're making them the external, they're the experts, they know. So if they say it's a taxa, we treat it as a taxa. If it's not there, we treat it as a functional group and the names go into the standard names. What we're trying to do is just to keep the number of standard names manageable. You've no idea how much effort had to go into with the P01 NVS equivalent to standard names has over 40,000 entries in it. And actually managing live searching and live serving of that, there's a huge amount of effort had to go into the technology behind that. The whole thing is buffered and it's held in its own triple store, and a massive amount of effort had to go in to make that work in real time. So the searches don't take half an hour, which web systems tend to say go bye-bye and shut themselves down with. So that's the philosophy that was behind that strategy. Yeah, so I'm trying to look at the chat as well.
Yeah, I'm trying to too. I'm trying to pick out. Yeah, did anyone else have a question they wanted, a discussion point they wanted to raise? Here?
Thanks, Abby. Yeah, you know, I'm hearing this. So if I'm putting on this hat where we're trying to build this whole data exchange system for the UN and bring biodiversity into ocean monitoring and related fields, earth and environment modeling, this what is being said in the chat now by some is exactly, I think, what we need. The users and data managers shouldn't have to worry terribly much which standard they're using, but they should rely on the fact, if you're describing an environmental parameter, that the standards organizations themselves have kind of made peace and created an authoritative mapping between one another. So you can auto convert between those two standards. So as John is aware, you know, we had this genetic working group that mapped the mixed standards to Darwin core. We used a triple SOM matrix, which maps it in a machine readable way with SCOS predicates. And we'd like to do the same in mix in the GSE. So putting on that board hat to the CF variables or other environmental parameters. Because right now we have packages of environmental parameters where we issue our own IRIs and descriptions, but then we're not really interoperable unless we, well, pull those in. I'd like that to happen. We still have to figure out how to do this. But at the same time, we don't want just another mapping, because what we've learned from mappings is that they're never really that precise. You're losing things on the way and errors propagate in data management, right? So I think what's being touched on by multiple people here, I think that's the inevitable thing in the value of this group too, in ESIP, the fact that these environmental metadata parameters are the core data to other fields. And we need this crosswalk between them, and so they're natively linked. And also that link is overseen by the people managing the standards. Otherwise, there will be drift, there'll be ad hoc decisions, and lots of error propagation that we can't control. So I don't know, I put that out there. I don't know, John, Roy, if you have thoughts on that or.
Well, of course, one of the issues with CF is the reality that it's a volunteer-driven community. Doesn't have a huge amount. There are efforts going on in this interoperability that are funded. Gwen Monkwafe, who took over my role in BODC on the vocabularies, is working with, have you heard of Guy Simon Cox in Australia?
Yeah, heard of him.
Well, they're working to develop an ontology that the objective is to get the NVS parameter descriptions and the standard names to interoperate. So there is work going on. I think I'm trying to think. I mean, it's getting information to people as to what's being done. And is it Research Data Alliance, RDA, is one of the, Gwen seems to do quite a lot of work with that. Again, I say I've been out of the front line for 4 years, and a lot has happened in that time, and I don't keep 100% in touch with this. My main role in CF is when someone comes up with biogeochemical standard name proposals, I'm probably the only person on the CF committee who's done any biology or biogeochemistry. So I'm doing the commenting and formatting, on approval stroke, getting those modified. Done a lot of work for HOTS recently, and also the Nansen project has now started asking for a series of new names, and I'm working on them at the moment.
Yeah, lots of connections here. That's part of why I wanted to start this cluster is RDA, Simon Cox is very well known in this ESIP community, and RDA is obviously also very well known. And so trying to make those connections here in ESIP, that's what we're trying to do with this cluster partially, and also just spread the word about standards for biological data. John, I didn't know if you had anything to add. Go ahead.
Yeah, just in terms of process and to follow up on what Pierre was saying. So in Darwin Core, the process is that if there's initiative for change, someone, because it's also entirely volunteer, someone who's a champion for a cause would create a task group within an appropriate interest group. The interest group might be Darwin Core, or it might be something broader. Create a task group to actually get something done. There are timelines, there are deliverables, it's all very formal, and it gets ratified, it gets reviewed and ratified. Then the task group goes on about its business and needs to report on it. The effectiveness of task groups depends on who leads them. And those people have to have a stake in what's coming out the other end. So with respect to the mixes work, we had people who were very engaged, and we got it all done very well, very fast. It was a pleasure. If it's not like that, it becomes a burden. We have several task groups right now related to Darwin Core running at the same time. This year has been like an explosion of people who are now satisfied with being able to publish what they can with Darwin Core and want to start hitting the frontiers with new stuff. But the process is good people leading a task group to get something actual done is the way it works.
Yeah, and Darwin Core is in that similar space where it's mostly volunteer, right, John? I mean, there's not a lot of funding in this to keep these things, going and moving and evolving, and so I think that's something I don't know what the answer is there, but.
Yeah, it's entirely volunteer, except insofar as the job that pay the salaries of the people involved allow them to work on it.
Yeah, Pierre, new task team to kind of work out all these connection details so that folks like Hassan don't have to worry about how they're connected. We can just build that into what we're doing. Makes sense. So any other last questions or discussion? We didn't really get a chance to cover what we want to do at the ESIP summer meeting. So I'll just put some thought into that. We are kind of considering, and maybe wanted to hear from you all, so maybe you could send me an email, or if you quickly have thoughts now about trying to help funders with data flow pathways that lead to, openly accessible data, how they might, and standards that would be applied, how that might go into funding proposals. Is an area we think could be useful, but could be a little fraught too, I think. So I'd be curious if that's a direction you all would want to go in the cluster, if that's something we should work on at the summer meeting in a session. But briefly, before people start to run off, I just want to say thank you so much, John and Roy, for taking the time today to come and talk to us about this and building these connections. It's really key, I think, for us all trying to do the work. So we really want to thank you.
Welcome.
It's super useful to be engaged with things that are happening outside the normal daily routine for me, to know where are we going with all of this.
Great. And Matt, did you want to put a plug in for the Marine Data Cluster meeting quickly?
Oh yeah, Marine Data Cluster is meeting this afternoon, I believe. But yeah, I'm not sure what you wanted me to plug.
Oh, sorry. Well, yeah, it's happening this afternoon and looking at vocabularies, right? So
yeah, right. Yeah, so we've been looking at controlled vocabularies for marine data, and so we've had a couple presentations from, one of them was the CS standard name list and NERC and those things, and we're trying to come up with at least a little bit of documentation as to what controlled vocabularies exist and what things might be useful for different types of observations. So we're trying to guide that into what a useful outcome might be.
yeah. So just kind of letting you all know that that's going on in case you're interested. So well, great. Well, thank you all so much for joining us, and thanks again, John and Roy, for coming and joining us. And we'll meet again. Our next meeting is supposed to be May 5th, I believe, but I haven't quite worked out the speakers for the controlled vocabulary section quite yet. So we might need to move it. So stay tuned. I'll send an email for sure. So thanks, everyone.
Bye, folks.
Oh.
Oof.